Right. I posted to Canvas information about an information technology career fair that will be held March 28th, which I think is next Monday. Let's see, what day is today? Today is the 21st, so I guess that'll be next Tuesday. Take a look at it, review the information. Probably would be a good thing for you to go to if you have the availability. I have paper flyers, so I'll hand them out to the people in the class. All right. Today you're gonna think I'm Dr. Phil today, because today we're talking about relationships, right? And we're talking about relationships in databases. Relationships in databases are a key aspect of databases, so much so, in fact, that what we usually abbreviate as databases, strictly speaking, are relational databases. And that's a big advantage of databases compared to the old way of doing things, where each piece of data or each group of data was in one file, in one entity. It was harder, not impossible, but it was harder to link data together and combine data in different ways. Plus, you ran into potential data integrity issues, like you might have an order without a valid customer. How would you have that? Well, there's bugs in programs. Maybe maybe you were able to delete a customer that had open orders. That might be a bug within the system, and the application would allow it because those relationships weren't embedded inside the database. But with databases, they are. And there's really three kinds of relationships, but we're going to focus on one of them, and I'll tell you why. First of all, when you count in the database world, there's only like three numbers in database design: 0, 1, and many. If it's more than one, it's many. So for example, a student can take how many classes? Well, students can take one class, that's true, but they can also take more than one class. So that's many. It doesn't matter that there's practical restrictions. There's only 24 hours to a day and 7 days a week. So a student can't practically take more than a certain number of credit hours. You're not probably going to build that constraint in the database. So kinds of relationships are one-to-one, usually shown that way. One to many, usually shown this way. And finally, there is many to many. And an example between a one-to-one relationship, these are kind of rare, all right? And it's almost, it's almost a little hard to even think of them. But one example might be the relationship between a dean and a division in a college. A division has a single dean, all right? At least we're saying so in this example. And a dean is only the dean of one division. At least we're saying so in this example. Now, in the real world, that might not be the case. It might be possible for someone might temporarily be the dean of two divisions. So even this might not necessarily be a great example of a one-to-one relationship. But it's about the best one I can come up with, especially within a school environment. One-to-many might be the relationship between department and courses. One department has multiple courses. A given course is for one department. So the department, let's say, is CISS. All right, that's the department. Each course has only one department. So there's CISS 121, CISS 216, CISS 243. All those belong to department CISS. Accounting 151, accounting 152. Those all belong to accounting. There's no courses that are accounting and CISS 121 or something like that. Each course belongs to one and only one department, but of course each department can have more than one course, like the example I gave before. In this case, usually put the ID of one as a foreign key and make it a unique index. But honestly, if you didn't get what I'm saying there, don't worry about it because we're not going to be dealing with any of these in this class, more than likely. One to many, though, what you do is the many sign points to the one. It's not possible to put an individual field in the department that can point to all the courses that a department has, but I can put for each course the department that course belongs to. And that's usually done with putting the primary key of this table in this table. And you don't just put the field in there, you enforce what's called a foreign key. A foreign key is where you formally tie a field in this table to the key of this table, such that you cannot add a course that doesn't have a valid department. So every course that you add has to have a valid department. Likewise, well, depending on the rule, you can enforce it that every course has to have a department. You can also make it optional in some cases. Maybe not in the course department situation, but in other cases. Also, I could not delete a department if there were courses associated with it, because that would orphan those courses. That would have courses floating out there for a non-existing department. So we have to take care of that in one way or another. And one of the ways to take care of it is by restricting deletion. Finally, we have many to many, and that might be the relationship between student and courses. Now, to test this out, we have to look in both directions. One student can have many courses. Each course can have many students. Now, this can't be implemented directly in a relational database. So what you do instead is you create an intersecting table and change this into two one-to-many relationships. So I have student, I have an enrollment table, and I have a course table. And this would have the key of both the student table and the course table as foreign keys to the other table. So I said there's three different kinds of relationship. Here they are. But this one's the important one, because this one is rare, and this one gets transformed into two one-to-many relationships. So really, most important relationship to consider is one-to-many, and that's what we're going to look at. So we're going to go over an example using a sample database from Microsoft, the Contoso University. Not sure exactly how you pronounce it, but there's tutorials for it. If we look in Canvas, in this week's module, you will see, here's the example from the tutorial. That's the database that I downloaded. If you download this application to your machine, be sure to update database because you have not updated the database yet. So I had to do that before I came to class today. Here's a detail about one-to-many relationships. in ASP.NET. Nice video about that. Here's the tutorial about the Contoso database. And I think there's another link to the tutorial. Let's spend a minute familiarizing yourself with it because we're going to spend a few weeks on this. So I want to make sure that we get it. All right. I think the first link sends us specifically to the one-to-many relationship, and the other one starts at the beginning of the tutorial. So let's run this. This is meant to be a database for a college. And we'll look at this. You run it. You have students, courses, instructors, and departments. There may be some other models involved in here. If we look at students, we can see a list of students. We can search by them. Also, there's 3 of these displayed per screen. Think of like Google search results, right? If you search HTML, the web page isn't going to have literally every single, it's going to show you every single search result. It's going to show you a page at a time, or in a lot of cases, if you're doing a search and you receive a list of products, like if an Amazon search, for example, if you search for a product, there's a next page of products or something like that. In Google, I think if you scroll, it automatically extends the list to more. I believe that's the case. But here we allow to go to the next and previous screen and only display a certain number at a time. That's especially important when we have a search that could return a lot of results. So for example, if I were to find by name Smith in a typical college, there's bound to be a few hundred people that have the last name of Smith. So we wouldn't want to burden the database or burden the screen by showing a list of 600 people with the last name of Smith. So would display them a certain number at a time and would scroll through them. A neat feature is we go to details, we see not just a student, but a list of the courses that they are taking, along with their grade. There's a student taking 3 courses. We see the list of courses along with their name. I think that's all I wanted to show you about students. Let's look at courses. We have a list of courses here. Details. Edit. We can associate the course with a department. And again, to implement the foreign key, we don't just allow someone to type in the department, we have a drop down for the department. That way we can show a list of the valid departments and allow the person to select that. Because remember, there's a foreign key built between department in courses and department in the department table. And we can't have a course with an invalid department. So therefore, you would not be just keying in the department number. It's better to select it from a list. Anytime you have a foreign key, don't allow the user to manually type in the value. Instead, use a drop-down. And we'll go over how to do a drop-down either in this class or in a future class. I think that's it for courses. Instructors. We show a list of instructors and we show a list of their courses. If I click select, it shows me again a list of their courses. And if I click select again, I see the students that are enrolled in that class. So I can see the detail for a professor, the detail for a class. That's a nice feature that we have. Editing also allows us to click on checkboxes to associate a class with a class with an instructor. Finally, we have departments. And the department has an instructor, someone who's their, I don't know what they call it, I don't know if they call it the dean or whatever, but like the person in charge of that department. We'd call that a program coordinator. We have a list of faculty people and you can select that and save it. Again, you don't want to, there's a foreign key relationship you don't want to allow the user just to type in something. You want to force the user to use a drop down or something else to select the values. Okay, that's the overview of the application. We'll be going over this and going over more parts of it later on. And we'll look to see how certain parts of it work. But the first thing I want to talk about is how the relationships are implemented. So if you remember, we are using the model first method, right? What is the model first method? The model first method is where we first define the models of all our entities. And starting now, we're also going to implement the relationships between those entities. We define that in the model, and we use that model to generate the database. There is the opposite approach, database first, where you create the database and then generate the models from the database. This, I would say, is the preferred, to do the models first. So let's look at, for example, the department model. Now, one thing about this application is good for illustrating some things. Some of the things are a little advanced, and some of the things I don't exactly agree with the way that they did it. So we're going to be selective about what we're going to look at in this example. By all means, look at as much of it as you want to, but I'm going to focus on the things that I think are important. So here's our department entity, our department class. We have an ID for department ID. Again, the scaffolding code is going to be smart, and the updating database code is going to be smart enough to know that that's the primary key. We have the name, the budget, start date, whatever that is. And then here is where we have the relationship. The concurrency token is something that we use to keep track if two people have updated the same thing. We're not going to really focus on that too much. But right here is how we implement the relationship between department and instructor. Did I draw that one? No. Let's draw it. And we'll implement the relationship between department and instructor and department and courses. The way this is set up Each department has one instructor that is their person in charge. So this might be a little counterintuitive, but there's a one-to-many relationship between instructor and department. Therefore, in database terms, we want an instructor ID here. Keeping in mind that that instructor ID represents the person in charge of the department. Or like I would call it the program coordinator. Now, a department has multiple courses. And therefore, there's going to be a department ID as a foreign key in the courses table. So how does this translate into our model? I have my instructor ID here. The question mark again next to the int means that it is optional. There might not be an instructor for a department. Let's say, for example, a instructor quit, all right, and they haven't yet assigned a new person to be in charge of that department. For a brief period of time, there might not be a person in charge of that department, all right? Or if you're just creating a brand new department and we're not sure who's going to be in charge of it yet, that might be another scenario. Anyhow, that's what the question mark means. So we put in as an attribute in here, we put in foreign key instructor ID. And again, the modeling is smart enough to know that this corresponds to the instructor table's ID, so it's going to create a foreign key for it. But notice what we also do. We create an instance of the object of type instructor called administrator. And that is going to be filled in with all the data from the instructor table about this instructor ID. So we are storing not just the instructor ID in the model, or storing maybe is the wrong word. We're not just putting the instructor ID in the model. We're putting in the single object for that instructor who is the administrator for this particular department. So if we want to know the instructor's name, guess what? We go to that instructor object and do administrator.name or administrator.fname or whatever the name is. Now, courses are different. We don't have a foreign key for courses over here. All right. However, we have a collection of courses in the department table that is going to be filled in with all the courses related to that department. So these are two objects. This is the object that contains the information for the one instructor related to that department, the administrator. Courses contains the list of all the courses related to that department. So if we write our query correctly, we can query all the departments and fill in the course information. And then we can loop through this list and display all the courses for a department, for example. Now let's look at these other two classes in the model. Let's look at course. All right, course ID, title, blah, 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 blah. This has a foreign key for department, and it has a single instance of a department object that represents the department that belongs to this department ID. In addition, we have a list of enrollment records and a list of instructors. Because again, according to this, think this comes in some other place. Oh, this is course. My mistake. I thought I was still on department. Yes, the course, there can be many instructors that teach a course. I don't have that represented here. Okay. We could look at more of these things. There is the instructor. That has the list of all the courses that they taught and the office assignment. We have the office assignment that consists of a instructor ID and location and has the single instructor that belongs with it. I'm going to focus right now on the department though. Or what do I want to focus on? Let's look at student. Student has a list of enrollments. An enrollment is the intersecting table between student and courses, and therefore has a course object and a student object listed to it. So let's run at this and let's see how this works. Let's look at students. Let's not. Let's look at the student details page. All right. Notice what happens. We have our students that we can list and we can search for. We're not going to worry about the searching and the paging of the list now. We're just going to look at one student. You can also, by the way, sort this list by enrollment ID or enrollment date or last name. We're going to look at this details page for students. All right, and we're going to see how that works. Because this navigates through from the student to the enrollment to the course table. Let me close this down for a second. If we get a list of students, we also get a list of the courses that they're enrolled in. And for each course that they're enrolled in, for each one of these enrollment, we get the course that the student is enrolled in. So again, in this particular part of the relationship, we have this. Student courses, and there's a many-to-many relationship that we have this intersecting table that is called enrollments. So in the model, the student is going to have a list of enrollments. The course is going to have a list of enrollments. And the enrollments table is going to have one student and one course per row. So one student object and one course in the model for a single enrollment. Student ID and one student, course ID and one course. List of enrollments in the course, list of enrollments in the student. Now, the one thing I didn't look at is look at the database. I don't look at the database too often in this class because you shouldn't be manipulating the database directly if you have any changes to make. If you have any changes to make, you should be going through and making the change to the model. For example, if I wanted an additional field in the student table, I would not go into the database and add it. I would add it to the model, create a migration, and then update the database. But it is good sometimes that you have, sometimes you need to look at the database. So we're going to look at the SQL Server Object Inspector, and we're going to look at the databases. And it's the school context. And here are our tables that got created. Course, the course instructor, the department, the enrollment, the instructor, the office assignment, and the student. If we look at the student, student has last name, first name, enrollment date. Course has course ID, title, credits, department ID. That enrollment has the foreign keys to both of those. Now in the model, notice we have both the foreign keys in there, and we have the object that that foreign key points to. And that makes it really cool. Let's see exactly how cool by looking at the student details page. So I'm going to look at pages, students, we'll look at details. Here is the here's the enrollment model. Let's open up the enrollment model, the student model, and the course model. Here's our code behind. All right. Now, let's run this and notice what happens when we run it. Because we have gone through these before, but we haven't maybe spent as much time as we should on them. So I want to spend a few time breaking this down and going through it. So when I click a student and click details, we were to look at this link. Look real close on the bottom, it says details question mark ID equals 1. ID equals 1 is the student ID. This detail page needs to know which student that we are interested in. Because I can't say give me student details. Well, give me student details for what student? Well, how do we identify students in the database? By the primary key. So we would give the student ID. This one says details ID equals 2, and so on. So when we click that, that's what we get up in the query string. All right, we're calling from students. We want the details razor page, and we're giving it the ID that we want. So keep that in the back of your mind. So let's look at the details page. I have a public student named student. All right. Student is the object of type student that we're going to fill in. We're going to fill in all the data into this student, and then we're going to display it on the Razor page. Because remember, that's how Razor pages work. The code behind fills in the data, and then the Razor page picks the stuff from the model, and by model, code behind, I mean pretty much the same thing. The Razor page picks the data from the model that it wants and displays it. So what we're going to do is our end goal is that we're going to retrieve this student and fill up this student's model. What does that student's model consist of? It consists of the ID, last name, first name, middle initial, enrollment date, their full name, which is actually a calculated attribute. There's only a get. In other words, you can't set the full name. You can only retrieve it, read only. And oh yes, we're going to fill up this list of enrollments. So this onGet is called, and it's passed maybe an ID. If it's not passed an ID, then we can't do anything with it, and therefore we return not found. So if for some reason we tried to call that student detail page, and we left off the ID, we get information saying that that page is not found. Now, here we have our link statement. And those fields, those lists in the model don't get filled in unless we tell it to fill it in. So I want the list from the database of all the students, but I also want to include for those students the list of enrollments. By saying include the student enrollments, what that will do is that will populate this list, the list of enrollment data for that student. Then I want to include for each enrollment the course information. So that will fill in the course information in the enrollment model. So we're getting back objects. We're getting back a student object that contains a list of enrollment objects. Each enrollment object has a list of, or has a single course object related to it. I think I might have said list when I was talking about course. There's actually a single one. So notice, any of you that have done SQL statements in database class know that this is a fairly simple way to do this. What effectively we have done is we've done a join between the student table, the enrollment table, and the course table. And what's more, we can refer to those things by their objects. So we're not just getting back a chunk of data back. We're actually getting a student object that has a list of enrollment objects. Each one of those enrollment objects has a course associated with it. First, to default, there's only going to be one. Here's where we filter by ID. Want those students where the ID of the student equals the ID that was passed to this, in other words, from the query string. If it doesn't find it, if there are no students, then students not found. That would be, for example, if I had a goofy ID like this, I get that it's not found. If it makes it to here, it means it's found a student. There was an ID on the query string, and we found the student that belongs to that ID. So now let's look at the Razor page. First part of the Razor page is going to look very similar to what we had before. We have a list, a data list, and we're displaying from the model the name for the student last name attribute, along with the student's last name. The name for the student's first or middle name, along with that value. The enrollment date, the title for enrollment date, the name for that column, along with the actual data. And then we have a loop. We display the name for the list of enrollments, which is just enrollments. And then we loop for each enrollment record in the model for the selected student. Student is the student that we filled in, and we also filled in the enrollment, so we can loop through those enrollments and we can display the title of the course and the grade. So item in this statement relates to an enrollment object. It relates to an enrollment object in the list of enrollment objects for that student. And we can display for that enrollment object the course for that enrollment object's title and the grade for that enrollment object. And we're done. The whole idea of this is we are able to fill in the related parts that we are interested in. We did not include filling in the student associated with the course because we didn't need it. We're not displaying the classmates for this student, all right, in a particular course. We only want the enrollment record and the course record. So we didn't bother filling in the student for that. Well, we already know who that student is. Actually, that wouldn't be classmates. It would be that very student. We already have that student, so we don't need to retrieve them again. Yeah, that would not be the classmates. I lost my head there. That would actually be, because it's not a list of students, it's a single student. So it would just be that student that we're retrieving. We see this in several places in this application. We see it when we look at departments, I think. No. We see it when we look at instructors and get a list of courses. And when we look at, yeah, we'll just look at this one right now. So if we look at the index of instructors, we'll notice it looks much like the indexes that we've seen before, but there's extra information. Let's look at the index. All right. Without going over this in detail, in the interest of time, it's real similar. We're retrieving the instructor data, and we're including the office assignment, and we're including the course. And for each course, we're including the department. So therefore, we can see the office that the person's assigned to, and we can see the list of courses on this instructor homepage. office, and here is a list of students, or not students, it's courses. If we look at this, the Razor page for it, we'll see how we loop for each course in the data and display the course title. All right, we're going to spend more time on this next week. We're going to study how to make a drop down. All right. This is key information as far as your project goes. And your project design document is due fairly soon. I don't remember the exact date, but check on Canvas. It might be due next week. All right. But at any rate, we'll talk about this more next week. Let me know if you have any questions. All right. I will see you next week. Or if anyone pops in lab, I will see you there.